Hello fellow problem solvers. So they're going to be doing a problem from Engel's problem solving strategies book on inequalities. So we have a, b, c are positive real numbers, and we show that a plus b plus c over abc is less than or equal to 1 over a squared plus 1 over b squared plus 1 over c squared. Now, what I would invite you to do here is try this problem out for a minimum of 5 minutes, ideally 15, but not more than half an hour. This is a technique building problem. We want to learn how to solve inequalities. So now, without further ado, let's begin. And what we need to do here is, okay, there's many approaches to take with inequalities, but the easiest approach is to see if both sides of the inequality are homogeneous. And here, given there's no condition, they have to be. And homogeneous means that everything on both sides is of the same degree. So here, this is really, if you take this plus, this is a over abc plus b over abc plus c over abc. So this thing right here is equal to 1 over bc plus 1 over, what do we have, ac plus 1 over ab, right? And now, there's many ways we can go about solving this. One way is when inequalities are homogeneous, you can usually group them together and use some sort of AMGM or Schur's inequality, arithmetic geometric mean inequalities. So here, there's two approaches, and now let's take both of them. One is to say, wait, this is awfully similar to a squared plus b squared is greater than or equal to a times 2 times a times b. And maybe there's something similar we can do here. And in fact, there is. If we look, say, if we take 1 over a squared plus 1 over b squared, by the arithmetic geometric mean inequality, we have that 1 over a squared plus 1 over b squared is greater than or equal to, this over 2 is going to be greater than or equal to the square root of 1 over a squared times 1 over b squared, which is equal to the square root of a squared b, 1 over a squared b squared, which is equal to 1 over 1 over a times b. And now if you see, we can apply the same sort of thing with b squared plus c squared, a squared plus c squared, over to sum up these inequalities. And inequalities you can sum up if they're of the same sign. We sum up these inequalities and we're done. So that is one way of doing this. Another way is you can, combine these terms together. Now me, when I solved this problem, I didn't do it like this. I said immediately, wait, these are all numbers which are fractions. I don't like fractions in inequalities. If I can help it, let me get rid of them. So I multiplied everything through by a squared, b squared, c squared right here. And what happens there is, this. We get this is true if and only if this is true. And now I saw, oh, this is somewhat a well-known inequality. Not that much, but this is actually a version of this is well-known, not this per se. But we have this thing right here is what we need to prove. This is true if and only if this is true. And the reason we can multiply is because a, b, and c are all positive real numbers, and so their product is a positive real number, ergo we can multiply everything out. And what happens now is we can do the same thing as before, combine this plus this, this plus this is greater than or equal to, it's going to be abc times b over 2. Actually, this plus this is greater than or equal to a times b times c times 2, and so on and so forth. And we can combine all of these together, we get that, or we need to prove. Another way of writing this down is to say this is true if and only if this thing right here is true, like this is a half times everything here is greater than or equal to 0, i.e. if this thing is greater than or equal to 0, which it is, because every single one of these is squares. Now the question is, when do we have equality here? And the equalities we have when every single one of these squares is equal to 0. So we have AB minus BC needs to be equal to 0. Now what does this mean? Well, b is greater than 0, so this means this is A minus C times B is 0. B isn't 0. So we have A minus C is 0, i.e. A is equal to C. And in a similar way, we get AB minus what do we need? AC is 0. A isn't equal to 0. So this implies that B minus C is 0, i.e. B is equal to C is equal to A. All of them need to be equal. And this solves our problem, and as always, thanks for problem solving.